Hello and welcome to Normally Distributed, where we learn about probability and statistics with a sports twist. Today I am bringing you Calculating and Interpreting Probability Part 3. If you tuned in for Parts 1 and 2, you learned that probability is a number between 0 and 1 that tells us the likelihood that an event will occur. We also learned some of the beginning steps in estimating probabilities from observational studies. In part 3, we're going to continue to learn about estimating probabilities, but this time we're going to learn about how to estimate probabilities when the probability of each outcome is not the same. Great, so now that we've worked through examples of when the probabilities are equal, let's go ahead and work through the probabilities when they are not equal. Now we know that in life, not everything has an equal probability, and you see this a lot in sports, where certain players have a higher probability of getting the offensive rebound or the defensive rebound because they're taller, because they're stronger, or because they're in the right spot. So let's go ahead and work through this example here. Let's ask the same question. We want to know whether the offensive team will get the rebound. And we have here listed their probabilities. So player A on the offensive team has a 3% chance of getting the rebound. Player B, 3% chance, and so on and so forth. You'll see that the sample space here is equal to 100 because this is everything that can happen. Somebody is going to get the rebound in this example. And so we have to figure out who it is. And so let's go ahead and look at whether or not the offensive team gets the rebound. In order to do that, we do it exactly the same as we did before. We just add up their individual probabilities. So we have 0.3, 0.03 plus 0.03. That gives us 0.06. This gives us 0.12. That's 0.18 and 0.25. So the sum of the offensive team's probability is 0.25, which means that the offensive team has a 25% chance of getting the rebound. Now, since we know that the sample space is equal to 100 or 1, if the offensive team has a 0.25 chance of getting the rebound, what does that mean for the defensive team? Without having to add up the numbers, we should know that that means that the defensive team has a 0.75 chance of getting the rebound. Finish this sentence here. 0.75 chance of getting the rebound. So in this example, the offensive team is unlikely to get the rebound, while the defensive team is likely to get the rebound. And that's typically what happens. Now, to have a little bit more fun, let's go ahead and do one more example here. Now, maybe we're not interested in just the offensive team. Let's say that offensive player D and E are what we're interested in. The coach really wants to know whether those two guys work well together and get a lot of offensive rebounds. And so he wants to calculate the probability that player D and E get the rebound. Again, when you have this option, whether player D or player E gets the ball, that means add. So one key word that you're going to want to know about probability is when people say or. That means one or the other, right? And in probability, that means plus. So when you hear the word or, whether player D or player E gets the offensive rebound, you want to add up their probabilities. So the probability that player D or E gets the rebound is equal to 0.06 plus 0.07, which gives them a probability of 0.13. 13% chance that they get the rebound. Not bad odds for an offensive team in my mind. But again, the major thing to emphasize here is or. So when we're looking at the previous example with the offensive team, we wanted to know whether the team on offense was going to get the rebound. So that means player A or player B or player C, D, or E could have gotten that rebound. And that is why we added up their probabilities. All right, so one thing that I think we need to define here are disjoint events. Now, disjoint events are events that cannot occur at the same time. If we go back to the previous example where I asked what is the probability that player D or player E gets the rebound, that's a great example of a disjoint event because we know in basketball, one player or the other gets the rebound, not both, right? So that is a perfect example of a disjoint. And what we do with disjoint events, if we want to find the probability of one or the other disjoint event happening, All we need to do is add those individual probabilities up, and we have the probability of either of them happening. Thank you for tuning in to Calculating and Interpreting Probabilities Part 3. Today we learned a lot about estimating probabilities when outcomes do not have the same probability, as well as disjoint events. For more learning resources and practice problems, please visit our website. If you like this video, hit the like button and subscribe. Thank you very much. Until next time.